Now, I'd like to make clear, this plate of the rollers was never intended to do this. It was particularly intended to be shown as a stationary three-dimensional model at the conference for future energy in Washington last November for the support of those on this lecture on this technology. Because of the mass interest, we decided that we could go further and do some experiment work to prove the missing information we need for the patent application. What you see is the proof of that experiment. Now, anyone saying it can't work must be feeling awful. Because here before their very eyes prove that not only will they stay on, they will actually rotate at a constant rate. When we increase the voltage, and we cannot go higher than the 7 volts we're using, because the space for them to rotate is not there. So we have to accept that this particular rate of velocity shown here is the maximum we dare go while we got these coils in the way in which we are doing our measurements. So where is that force coming from that is now constantly accelerating that? Right, now we look what happens when there's 2. Maybe it's best to put that as the marker. We'll put that to line up as a marker so that one can see what that does. Right, now if we put the part on that low, it won't run because it's sitting at the bottom of the trough until the trough is excited. It shouldn't run until the trough is excited. We leave it there so that it's sitting still. Now we see how Newton's law behaves when we insert the second one. Right, nothing's happened. Now if I bring this over to the trough, so what we see here, that there is on one a little bit more forceful moment acting. That is probably due to the interaction between the one already there and the one that is added to it. Now balance out, I think that can be seen now quite clearly. Newton's law is upheld. Now continuing at constant speed, at constant distance from each other. Newton is wrong. I see. We really want to get one to the front. Is that all right?
Okay.
Right. Now we've got 3 rollers, and at the moment nothing is added in force. Now we're going to gently itch this forward until it feels a force. It's clearly that Newton's law still holds true. They are travelling at constant speed. Each roller is exerting a force on the left one, and the chain reaction is happening between the rollers. So far, we haven't broken Newton's law. Now, what we've seen here is it comes into the law of the squares, which will be dealt with later. But we still keep to Newton's law for the moment in our discussion. Right, we're now place 4. Now, look carefully how they're positioned. Now, they're positioned because it's like a spring. It's select one of the tip in the spring or the top of the wave. Now we'll try to make sure some force is applied. The force applied is negligible, but Newton's laws are upheld. They're still travelling at constant speed, and interreactions between roller and roller are keeping a set distance. But because the wave on it is set for 12 rollers, the wave gets stretched a bit at certain points. Get it. They are moving, even though it's a tiny force that was applied. It is underway based on the force acting on it. So between this and here, there's a force, quite a large one. Yet it's only a little force that we are excited with. It rather reminds me of Albert Einstein, when he stated that the atom had this gigantic amount of energy in it. It would take too much energy to get that out, so it wouldn't be worth it. Of course, we proved he's wrong. The same picture here. One would think it takes a lot of energy to make this happen. Yet it doesn't. It was only taking roughly 7 volts and around about 600 milliamps to produce this force. And this is the interesting point, that every line of flux that is cutting a line of conductor will induce electricity. The faster this goes, the higher will that voltage induce be, and current is proportional to the voltage. So the higher we can get this voltage up, we can then step it down to get the current we require. That's not complicated to do, that's being done all the time. All we're doing is show that we can use a very small force to get a very big force out of it. Newton, law still upheld. Nothing wrong with Newton's law. These rollers are travelling at constant speed, exactly as Newton explained. Well, we're breaking the laws of physics. Yeah, show me.